want to talk about how we graph absolute value equations. So remember that the absolute value of a number is just that number, but you don't have a negative sign if it's negative. So it's the positive version of any number. So if it's positive, it stays positive. If it's negative, it becomes negative. So let's make a little chart of x and y values here. Let's do -2, -1, 0, 1, and 2. So we're going to just start by graphing the simplest possible absolute value equation. So remember that it becomes positive if it's negative. So -2 becomes 2, -1 becomes 1, 0, and then 1 and 2 stay themselves. So if we graph that, -2 is over here, or -2 is here, -1, 1 is here, 0, 1, 1, and then 2, 2 is here. So if we graph it, it's going to look like a V shape. So it makes a V-shaped graph, and absolute value equations are always going to make a V-shaped graph, and that's because part of it, the y, it doesn't change the sign, and another part of it does change the sign. So absolute value equations always make a V-shaped graph, but more complicated absolute value equations are going to be a little bit different. So I want to start by looking at y equals the absolute value of x minus 3. So let's go ahead and put some of this into a chart. So put some of these into a chart. So let's put in 0, 1, 2, 3, 4, 5. Let's try those. Okay, so 0 minus 3 is -3, and -3 becomes +3 in the absolute value. -1 minus 3 is -2, which becomes +2 in the absolute value. 2 minus 3 is -1, and that becomes 1 in the absolute value. 3 minus 3 is 0, and 4 minus 3 is 1, which stays 1 in the absolute value, and then 5 minus 3 is 2, which stays 2 in the absolute value. So let's go ahead and graph these points. 0, 3, 1, 2, 2, 1, 3, 0, 4, 1, and 5, 2. Can you see the V shape that we're starting to make? So let's go ahead and draw this one. And so this is the V shape that we're starting to make. And this absolute value equation is moved over from the original blue one. It's moved over to the right 3. And this point right here is called the vertex. And the blue one has one too. So this is also the vertex. So the vertex is the place where the V changes, from going down to going up, or changes from increasing to decreasing. This is called the vertex. The vertex always happens when the stuff inside the absolute value is equal to 0. And that should make sense because that's where it changes from the absolute value turning things positive to the absolute value doing nothing, right? Is where this equals 0. So whatever is inside the absolute value, in this case it's x minus 3. Wherever x minus 3 is equal to 0, that's where the vertex is in terms of the x. So in this case, it's where x equals 3. This is the x value of the vertex. Okay, so that's going to help us. So let's remember that the x value of the vertex is wherever the inside of the absolute value is equal to 0. Okay, now I'm just going to get a new screen here. So now I want to try a much more complicated equation, or somewhat more complicated equation, I guess. It's not terribly complicated. Y equals the absolute value of x plus 1 plus 3. Okay, so we know that the vertex is going to happen where x plus 1 equals 0. So the x value of the vertex is going to be negative 1. So let's go ahead and put that into our function. Let's make a table, but let's start with the vertex. So starting with the vertex, where x is negative 1, that would be 0 plus 3. So negative 1, positive 3. This is the vertex. So we know it's going to make a V shape, and we know that the vertex is going to be here. So let's go ahead and do points around this point to figure out what it's going to look like. So let's do negative 2 and let's do 0. So when we put in negative 2, we get negative 2 plus 1. That's negative 1. That becomes positive 1. So that's positive 1 plus 3 is 4. So negative 2, 4. Okay, let's try 0. So if we put in 0 plus 1 is 1. That stays 1. Plus 3 is 4. So our V shape is going to look like this. So you don't have to go searching around for the vertex. If you know what that x value of the vertex is going to be, you don't have to go looking for it. You can just use the points that you need to use. But we'll talk about a little bit more systematic ways of doing this too. So once you have 3 points for the absolute value, including the vertex, you can go ahead and graph it. So there's that. Okay. So let's try to think now about what happened as a result of the plus 3. So on the previous 2 graphs, they all were starting at 0, right? The one started at 0, 0, and then the other one started at 3, 0. This plus 3 makes everything, the y values of everything, go up 3, right? At the end, after we do whatever's in the absolute value, we just add 3 to everything. Well, that makes it go up 3. So this is what makes it go up 3. And if this was a negative, it would make it go down 3. Okay, let me erase a little bit of that. And let's try one more. So let's try y equals negative 2 absolute value of x minus 1 plus 1. Okay, so now this one's really complicated, right? And we'll try to see if we can graph it and then see if we can figure out what makes different things happen. So we're going to start with what we know, and we know that whatever's inside the absolute value, where that equals 0, that's where the vertex is. So in this case, it's going to be x equals positive 1. So when I do my chart, I'm going to put in x equals 1 as one of my values, and I'm going to plug it in here. So if x equals 1, this part equals 0. So negative 2 times 0 is 0, plus 1 is just 1. So my vertex is happening at 1, 1. Now, let me put in values around that to see what's happening. So let's put in 0 and let's put in 2. So if I put in 0, I have 0 minus 1 is negative 1. The absolute value of negative 1 is positive 1. And then, so we're taking negative 2 times that absolute value of negative 1, which is positive 1, plus 1. So negative 2 times 1 is negative 2, plus 1 is negative 1. So now we have we're going to put in 2. So 2 minus 1 is 1. Negative 2 times 1 is 1. Negative 2 times 1 is negative 2. Plus 1 is negative 1. So this is also negative 1. Okay, so we have 0, negative 1, and we have 2, negative 1. And this should be enough information to graph it. So I'm going to line up these points. Okay, so this is what this absolute value equation looks like. So now let's try to go back and see what's causing what. So we know that the vertex is at 1, 1, but why is it facing down? This one has a V that's upside down, and what is the cause of that? So you might be guessing the cause of it facing upside down is this negative. This is going to tell whether it's facing down or up. So in this case, this is a positive coefficient here. You can't see it, it's just a 1. But that means that it's facing up. So these are going to face up, but if it has a negative out front, then it's going to face down. Okay, so now you might also notice that the slope is different. So this has a slope of 1, right? Up 1 over 1, up 1 over 1. And over here it has a slope of negative 1, up 1 to the left 1. But this one has a slope of 2. It has down 2 over 1, right? Or negative 2 really. Down 2, here is positive 2. Down 2 to the left 1, or up 2 over 1. So the slope here is 2, whereas the slope here is 1. That's because of the number right here. So this is just a 1 right here, whereas this has 2. So this is the slope. And then this number inside tells us the x value of the vertex. And then this number outside, this actually tells us the y value of the vertex. So whatever this number is, that's how much we move the whole thing up or down. So like this plus 3 is the y value of the vertex, and here the plus 1 is the x value of the vertex. But in order to graph it, all you really need to do is first figure out what the x value of the vertex is by looking at what's inside here and what makes it 0. Then put it into a table and then plot values nearby. Once you plot some nearby values, you'll be able to find the shape of your V. If you don't want to do it by sort of deconstructing the whole thing. But either way works. And that's how we graph an absolute value equation.